Well, hello everyone. This is Frank, and today we're going to be working on a DFIR video on memory forensics, specifically processor forensics. We're going to be diving into some malware, Stuxnet, right? A very popular, great case study that affected the Iran's nuclear program. One piece of malware that infiltrated both the centrifuges and the computer systems in an air gap network. So we'll be using a tool called Volatility, right? They are the ex de facto memory analysis tool. Let me show you their website. If we look at their webpage, which is simply volatilityfoundation.org, you're going to see that they have a lot of work into this here. Scroll down a little bit, you can see they're a 501c. Just like my foundation, the OWASP Foundation, I, of course, run the Denver branch. We have the training and the contest in there. And if you do use these tools, I really want to encourage you to donate to them. I mean, as you can see here, it is FOSS, free and open source. But again, if you use this tool, donate, shoot them a little money through PayPal, really just to show some appreciation for the great work they did. I've done it. I encourage you to do that as well.
Task 1. Run image info to create a base for the upcoming tasks.
Just to baseline where we're at, we're going to go ahead and run the pwd command, which is present working directory. We're going to list what's in there with the long format. And the file we need is on the desktop. So we're going to go cd desktop. Again, list, and there we see the Stuxnet vmem. Now remember that this is not the malware. This is simply the memory file or the memory dump from it. Now that we know what the file is, we're going to run volatility against that file. So we're going to do a -f. And then we're going to put the Stuxnet vmem inside there. And we're going to ask for the image info. It's going to look it up in the KDBG, right, database. And we can see in the suggested profiles a couple of different guesses. We see Windows XP, Service Pack 2, x86, and what we're specifically looking at is, of course, Windows XP, Service Pack 2, so major revision, and then x86 is the Intel chipset.
Task 2. Run pslist and pstree to identify processes.
We'll start off with the volatility command. Of course, the hardest part about volatility is spelling volatility. I'm going to name the image -f stuxnet.vmem. I'm going to add in the profile that we had before, which is profile of Windows XP SP2 x86. And we're going to run pslist. And this is going to show us all the running processes that we have on the machine or within inside the memory. I'm going to scroll up so we can see the top of the columns here. We have PID or process ID, PPID, parent process ID, threads, handles, right, and session ID. I'm going to scroll back down, and what I see is two LSAS processes down here. Now, there was one up top, so there should only be one LSAS process running, which makes the other two or three of these as suspicious. We're going to run a similar but different command. I'm just going to hit an up arrow and I'm going to run pstree. Now, pstree looks very similar to pslist, but if you look at the dots on the side, they're sub-processes through each one. So in this specific case, we see that SMSS is a subprocessor of system, and CSRSS is a subprocess of SMSS, and then when logon is a subprocess of CSRSS.
Task 3. Running ConScan to see any active connections. Running sockets to see what the system is listening on.
I'm going to go ahead and clear the screen. You technically don't need to do that, but from demonstration purposes, I think it's always easier to have a clear screen. I'm going to hit the up arrow and type in ConScan. ConScan shows us all our active connections. This is similar if we're looking at a live system to netstat-ANO. As you can see, there are no active connections. That's okay. Remember that this is a moment in time memory acquisitions. Maybe it was a few minutes earlier, maybe it was hours earlier, maybe it's after the fact. We're going to go ahead and run the sockets command. And as you can see here, we see both 500 and 4500 for UDP. Those are VPN ports. We see 445 for SMB, 135 which are legacy Windows ports. And the first question you should be asking is, why is a Windows workstation listening for a VPN connection? Not outbound, but inbound.
Task 4. Run DLL list to observe the dynamic link libraries the processes are using.
We're going to jump into our next task here. First off, I'm going to start the screen, and we're going to get into DLL list. Oops, not DLL list, just like that. I'm going to go ahead and up arrow, and then go ahead and change the command to DLL list. And as we scroll through, we can see all the DLLs that were affected by each process, including the LSAS at 1928. So now we see NTDLL, kernel 32DLL. If we start looking these up, we're going to find out that they are for core services or system services within Windows. We're going to focus in on a process ID that caught our eye earlier. So we're going to go to the DLL list dash process ID and the process ID that we noted earlier, which was 1928. And we see all the different DLLs that were affected by this process list. And you can see it is a very, very long list. Let's return back to a previous command, pslist, and let's go back and focus on that lsas command. Now, on the screen, we see 868 for the process ID and 1928 for the process ID. Remember, there should only be one instance of this running. Let's go ahead and see if we can find any others. So for the LSAS, and now we pull up 3 processes for the LSAS. We've added 680 to the list.
Task 5. Running malfind to investigate each suspicious process for malware.
One of the most awesome things about Volatility is it has a malware finding module or malware analysis module. So we're going to investigate each one of these rogue processes with the malfind tool. I'm going to go ahead and type in malfind -s process ID. And we're just going to start with the lowest one, which is 680. Okay, comes back. All right. Let's look at the next one though, 868. All right. Oh, got some mistakes in there. Oops. Let's try this again. Oh, and there's a lot of data in here now. What is going on with this? All right. I'm going to scroll up, scroll up, scroll up, and wow. So this is an advantage that we have today is let's use AI to go ahead and find out what's going on. I'm going to go ahead and highlight everything and put it into a document. And I'm going to drop that into Claude. Claude, I tend to lean to Claude for a lot of these type of analysis. I personally think it does a better job. I put the results into Claude and let's look at what Claude says. Suspicious memory regions detected. Right? I asked Claude, of course, to help me analyze these results, and that's what it came up with. So, region 1, page does not read write. Why this is malicious. And we can start seeing some of the other things that are out there. Even gives us recommended next steps with the volatility tool. So we're going to try that next. We're going to also investigate, though, first that last process for LSAS. Before we run that final command, let's go ahead and check out that last process ID, which is 1928. And looks like we have very, very similar results. Let's go ahead and try that command that Claude suggested, and which is vod dump. Right? Oh, I have a little tick mark at the very beginning that's going to cause a problem. Try to run the command. Oh, output slash is not a directory, as you can see at the very end of that command. So if I try to remove it, right, says, well, wait a minute, I did a -d, which requires the output directory. So let's go ahead and just make that directory. Make directory, output, enter. Up arrow a couple times. Let's try that command again. And it created a dump file. Let's go ahead and create a hash of the file for integrity purposes. We're going to go ahead and use MD5 since this is a lab machine and lots of low power. First thing I'm going to do is change over to the output directory. And then I'm going to go ahead and look at the file, ls-l, and then run MD5 sum on the actual file. And you can see when my hash is here. Again, this is how we'll verify that integrity once we load it up to our evidence.
Task 6. Breaking down the results of malfind into a dump file for further analysis.
Before we start dumping the processes, we're going to need to create a directory to put the data in. So we're going to do make directory proc-dump. We're going to up arrow to volatility, the last command, and we're going to go change that to malfind -- process ID, and we're going to call the dump directory, which is the one that we just created, which was proc-dump. I hit enter, and because I'm in the output directory, it can't find that proc dump. So I'm going to go ahead and just do cd space ... go back to the desktop and try the command again, which is where I actually created that proc-dump directory. Or at least I'm going to try it again here. And there we go. We put the data into that directory. We're going to want to repeat this for the other two LSAS process IDs. As you can see here, we have the dump directory. We're going to run our MD5 sum. Again, MD5 is not the best way to do it, but limited power since this is a lab machine and in the cloud. Now what we're going to do is upload those dump files along with the hashes to our evidence directory. Well, I hope you enjoyed that video, or at least got some educational benefits from it. Please follow me on LinkedIn. On LinkedIn, I'm simply Frank Victory, and you can follow me there. I am also the president of the Denver chapter of OWASP, so please check out our LinkedIn page there. And also Snowfrock, which is our annual conference that's coming up for 2026. It'll be April 16th and 17th at the Cable Center. For those of you that are familiar with that conference, that's the first time that we're going to be running a 2-day conference. I also have a podcast, or working on a podcast, for Colorado Equals Security. You can find it on your favorite podcast app or colorado-security.com. Thank you again. Hope to see you soon.